So today we are going to learn about the various characteristics of the process of electrolysis. So like I told you that the cations or the positive ions will move towards the cathode and the negative ions or the anions will move towards the anode. So this is one property. Obviously there are many other such properties which we will learn. The passage of electricity through an electrolyte causes the positive ions, that is the cations, to migrate towards the cathode and the negative ions, that is the anions, to migrate towards the anode, which I just told. The number of electrons which is gained by the anode is equal to the number of electrons given by the cathode. Like I told you, in case of a cathode and in case of an anode, there will be oxidation and reduction. We will learn which one will occur where. Okay, so we know oxidation means loss of electrons and reduction means gain of electrons. So how many electrons are lost, that many will be gained. So there is no extra electrons remaining in the solution. It will be matched up. The products of electrolysis are formed at the cathode and at the anode. Yes, we will learn about this also in the later parts of the chapter. Whatever products are formed at the end of cathode and anode, that will be formed near the electrodes or on the electrodes. They will not be formed elsewhere. They will be formed, if it is a gas, it will be formed near the cathode and the anode. If it is a solid, it will be formed on the cathode or the anode. Next, the process of electrolysis is a redox reaction because oxidation also occurs and reduction also occurs together. There is a loss of electrons and there is a gain of electrons together simultaneously. Therefore, it is a redox reaction. Also, electrolysis is always caused by direct current, not by alternating current. Alternating current is a type of current which changes its direction after every after every cycle, you can say. Okay, so AC current and DC current, we have these two things. We'll learn about AC current in more detail in physics. Only one thing you have to remember over here, that direct current is used in electrolysis. So these points are very important. You can underline these points specifically in your book. Next is differentiation between dissociation and ionization. These two terms look and seem to be very common, but they have a major difference between them. What is it? So dissociation means breaking of ions which were already there in the solid, and ionization means formation of ions which were not present in the solid or in the liquid or in the gas. So dissociation is actually the separation of ions in case of ionic compounds. Like for example, in NaCl, like I told you in the first video itself, that whenever it is dissolved in water or whenever it is melted, it will separate into sodium ions and chloride ions. So these ions were already present in sodium chloride, but they are not breaking apart until and unless they will be dissolved in water or it is present in the molten state. So the ions were already present, but they are just breaking apart in the presence of aqueous solution or on melting. So this procedure is known as electrolytic dissociation. Ions were already there, but those ions are now getting separated. Now in case of ionization, ions were not there initially, but on mixing with water, ions are forming. Okay, ions were not initially present, but now they are forming on dissolving in water. So in which type of compounds they can occur? Only in polar covalent compounds such as HCl, HF, etc. So I told about this in the first video itself, that we have different types of electrolytes. We have ionic compounds such as NaCl, MgCl2, etc. So in case of ionic compounds, it will be electrolytic dissociation because the ions were already present. But in case of polar covalent compounds such as HCl and all, it will be called ionization. So here in the next page we have a comparison between these two. The same thing which I just told you, it has been repeated. So you can go through this and understand the difference between ionization and dissociation. Next we have the electrochemical series, which you all have studied in class 8 most probably, depending upon which ion can be displaced. Right, in displacement reaction you have studied about this. So over here we are going to learn about them once again, but what is its use in this chapter we will see. So what is the electrochemical series basically? Based on the ease with which atoms of metals lose electrons to form positively charged ions, the metals are arranged in a series known as electrochemical series. Through the trend of an electrochemical series, we can also say that the atoms which are present on the top of the list, they are much more reactive as compared to the atoms which are at the bottom. So if we consider the trend of metals, potassium, calcium, sodium, magnesium, all this, whatever is above hydrogen, those are quite reactive metals, but as we are moving downwards, they are very non-reactive, like gold, platinum, silver, etc. Right? So what happens? Increasing ease of discharge at cathodes. We will learn what does this sentence mean, what does this actually imply. We will learn in the next part of the chapter. So this series of metals through which we can understand whether they are reactive or not, whether they can easily form an ion by losing of electron, this series is known as the electrochemical series. So during electrolysis, if in the solution two different metals are present, which one will go to the cathode out of both of them, that will be determined by the electrochemical series. So let's see. Preferential or selective discharge of ions at electrodes. I just told you about the electrochemical series for metals or for cations. We also have it for anions. We will come to that later. But before that, once let us see on the basis of what the ions will be will go to the cathode or to the anode. If there are two metal ions present, which of them will go to the which one of them will go to the cathode, and if there are two non-metals present or two negative ions present, which one will go to the anode. So it is based on a number of factors. The first one is the relative position of the ions in the electrochemical series. So the electrochemical series which we just discussed, based on its position also, we can understand which ion will be discharged first or which ion will go to the cathode first. The relative concentration of ions. So if one ion is present in a larger quantity and if the other ions are present in a very small quantity, in that case what will happen, that also we are going to learn. And next, the nature of the electrodes. If the electrodes are made up of an inert metal, like which will not react, in that case what will happen, we will see examples also related to that. And if the electrode is made up of a reactive metal, in that case what will happen, which ion will get discharged. So we are going to learn about these things also. So before that, let us also see the electrochemical series of anions. Same thing again, the ease with which non-metals can form ions, that means anions, or you can say the reactivity, how much they are reactive. So we have first of all sulfate, then nitrate, chloride, bromide, iodide and hydroxide. So we are going to learn what actually happens in case there are two anions present in the solution, or if there are two cations present in the solution, which one will get discharged quickly and which one will not get discharged at all. So over here it has been written, lower the position of the anion in the series, more easily it gets discharged at the anode. Yes. So if we see the electrochemical series, we see that first we have sulfate, then we have nitrate, and then it goes on till hydroxide. So if in a solution we have hydroxide OH minus and sulfate SO4 2 minus, out of these two, which one will go to the anode? It will be the one which is lower in the electrochemical series. So it will be hydroxide ions which will be discharged. So this is the first point. And next one is higher the position of the anion, more difficult it is to lose electrons and get oxidized. Yes, the same thing, it has been repeated in a different way. If the anion is present at the upper part of the electrochemical series, that means if we consider sulfate, nitrate and all, they find it difficult to go to the anode. So this is a problem for them. So the lower we go in the electrochemical series, all the bottommost ions, they can easily get discharged at the anode. That means they will easily go to the anode during the electrolysis process. Similarly, in case of cations also, we can see that increasing ease of discharge at cathode. Lower the ion in the electrochemical series, they will easily get discharged at the cathode. So all the ions which are in the lowermost position, they find it easy to move to the cathode and the anode respectively. So let us read about these points about the selective discharge or the preferential discharge, that is which ion will go first or which ion will go to the anode or the cathode in detail now. If all the other factors are constant, any ion lower in the electrochemical series get discharged at the relevant electrode in preference to those above it. Yes, like we just discussed, lower the ion in the electrochemical series, easy it will be for that ion to get discharged at the cathode or the anode respectively. Concentration of ions in the electrolyte. This is a very interesting and important one. If an electrolyte has a much higher concentration of a particular ion, then that ion will be discharged at the relevant electrode in reference to those ions which are lower in the electrochemical series but are present along with. So more the quantity of the ions in the solution, easily it will get discharged. Obviously, since they are present more in number, they will have an upper hand in this case. So if we consider that sulfate ions are present and OH minus ions are present, hydroxide ions are present, sulfate ions will find it difficult to get discharged at the anode, obviously, because it is located in the top part of the electrochemical series. But if sulfate ions are present in a large amount compared to hydroxide ions, it will be the sulfate ions which will get discharged. So depending upon the amount of ions which is present, that is also a very important factor in determining which ion will go first to which electrode. So also there is another criteria depending upon which the ions are preferably discharged at the cathode or the anode, that is the nature of electrodes used. So there can be two types of electrodes which are used. One is active electrode and one is inert electrode. As the name suggests, inert electrode is the one which will not take part in the reaction. It will remain inert. It is not doing anything in the reaction. And active electrode is the one which will take part in the reaction, which is reactive. So when we learn about electrolysis of copper sulfate in the later parts of the chapter, we will understand about this in detail. So for now, let me again recapitulate to you what was electrodes. Electrodes were the metallic rods or the non-metallic rods which were placed in the electrolyte, and it would complete the circuit for the process of electrolysis. The electrode which was connected to the negative side of the battery was called the cathode, and the electrode which was connected to the positive side of the battery is known as the anode. Cations go towards the cathode and anions go towards the anode. So this is the gist of the entire topic. So over here in the example also it has been written about the electrolysis of copper sulfate. We will learn about this in detail in the later parts of the chapter. So our first electrolysis is electrolysis of molten lead bromide. Since lead bromide is insoluble in water, we will melt it and we will utilize it as the electrolyte. The temperature has to be maintained above 380 degrees Celsius. We have to continuously heat the voltmeter or the electrolytic cell because molten lead bromide solidifies very quickly. Next, the electrolytic cell is made up of silica. Why? Because silica is non-reactive and it can withstand a very high amount of temperature. I would urge you all to underline the properties of silica which makes it a good electrolytic cell. And it is almost a non-conductor of electricity. So it will not even conduct electricity. So it is completely inert. So these are the properties of silica which helps it to be used as an electrolytic cell. Electrodes are graphite rods or graphite plates. Graphite is inert in this case. It will not take part in the reaction. Hence we use graphite. So since our solution or our electrolytic solution is molten lead bromide, therefore what would be the two ions which would be formed here? Lead and bromine ion. Obviously there is no other ion formed. There is no water in this case. So hydrogen ions or OH minus ions, none of them are present. Only lead ions and bromide ions are present. So I told you cations will move towards the cathode and anions will move towards the anode, right? And in cathode what happens? Reduction occurs, gain of electrons occur, and in anode oxidation occurs or loss of electrons occur. So let us write. In cathode, first of all, lead ion is going, and in case of anode, bromide ion is going. So how can lead ion get converted into a metallic atom? It has 2 electrons less, so it has to gain 2 electrons in order to become an atom. So 2 electrons are added and it will become lead atom. So since electrons are added, that means it is reduction. Now in case of bromide ion, it has Br minus, negative sign. That means it has 1 electron extra. That means it has to lose this 1 electron in order to become a bromine atom. So it will lose 1 electron and it will get converted into Br. So loss of electrons means oxidation. So see, in anode oxidation occurs. But bromine is a diatomic gas. It cannot exist in this form. So bromine will react with another bromine atom and it will form Br2. So in the anode place, you will observe that a reddish brown gas is evolved, and in the cathode region, you will find a grayish metal deposit on the cathode. Like I told you that the electrodes are the places where the products of electrolysis will be formed. If it is a gas, it will be formed around it, and if it is a solid, it will be formed on it. So since lead is a solid, it will be formed on the cathode region, And since bromine is a gas, it will be seen in the anode region as a brownish gas. So there are certain important points in the next part of this electrolysis. Let's see. Since silica is non-reactive, hence it is used in the electrolytic cell. Yeah, the same thing has been written once again. Another thing is it is heated slowly from outside. As you can see over here, there is a burner in the bottom which is continuously heating the mixture. Not the mixture, the compound, so that it does not solidifies quickly. As soon as lead bromide is melted, the ions which were present in it, they are becoming free, they are becoming mobile, and they can move throughout the solution, and as a result they can transfer electricity. So these ions are similar to the free electrons which we have learned in the first video, which are present in a conductor. So in this case, since lead bromide is an ionic compound, so it will be electrolytic dissociation, not ionization. And why graphite anode is preferred? I told you it is inert, so all the bromine vapors are present are produced in the anode region, but still it is not reacting with those bromine vapors. The graphite is remaining inert, it is unreactive. So these are the reasons why silica is used in the crucible, why graphite electrodes are used. Questions can be asked from this topic.